Let me share my presentation, sir. So, meantime, really, earlier lecture was very good. It was very elaborated, and really, it is useful for many of us. We can utilize the remote sensing applications in different fields, including data analysis and uh, soil moisture estimation, water balance, etc., water application. So it is really very wonderful. I could join the lecture at some late because I had class, but really it is very good and appreciable, sir. So just yeah, full screen is visible, sir. Yeah. So, very good morning, everyone. Myself, Dr. Sudhir Kumar Mishra. In last lecture, we have discussed that I have been working at Punjab Agricultural University, Ludhiana, since last 10 and 11 years. And recently, I have joined the Indian Council of Agriculture Research, National Institute of Abiotic Stress Management at Baramati, Pune, as a senior scientist in agricultural meteorology. So my previous work is mainly focused on the application of agrometeorological services to the farmers under the Gramin Krishi Mosam Seva scheme funded by your previous institution, India Meteorological Department, Ministry of Earth Sciences. And now I have shifted from there to little bit higher institute at the ICAR. So what I have assigned the topic today, that is applied agricultural climate. I will be discussing on this topic. So simply applied climatology is the study of the effects of climate on natural and social systems. It is the scientific analysis of climatic data in the light of useful applications for an operational purpose. This is definitions given by just 1 minute, sir. Screen has some blur. Yes, it is achieved and real-time climate information to solve a variety of social, economic, and environmental problems for clients and managers in fields such as agriculture, industry, and energies. Applied climatology is the science use of climatic data and theoretical constructions for the solution of a particular problem. This is definition given by Martoj in 1989. Sir, I will share my screen again because there is some problem in the screen sharing. Is it visible, sir? No. Just I'm sharing entire screen. Now it is visual clearly, I think. Uh, Now it is visual. Okay. Yeah, I made it, sir, at my screen. Sir. Yes, sir. Is it visible? Okay, sorry, sir. Internet connection was lost. Yeah. So, climatology has been described in different subgroups like climatography, physical climatology, dynamic climatology, applied climatology, and all these subgroups has different analytical approach using descriptive, statistical, mathematical, and synoptic analysis. It services of the climatology, applications of the climatology can be extended over different scales, including microclimatology, mesoclimatology, and micro scale climatology. So it is very important for us, the agriculture scientists, that how we can utilize the informations of the climatology in the agriculture, that we combine the climatological services with the agricultural uh, uh, information, that it may be very good for the rendering agricultural services to different sectors, including farmers, scientists, and policy makers. So, the agriculture climatology may be a branch of science that concerns with the influence of climate and cultural conditions, practices of the plants, animal husbandry, etc. It may be a detrimental influence, especially on the biological and weather conditions and agricultural operations in general. So, how agricultural climatology can be useful with the agriculture? So, we know that crop growth and productivity is dependent on the different biotic parameters like temperature, rainfall, salinity, and wind speed. So these information is generated using different source, using surface observatory data, climate, remote sensing informations, and when we integrate these climatic data with the outputs of the crop and agriculture, then we can have very good agricultural planning in terms of the water management, nutrient management, and we can assess the influence of the soil and water and nutrients on the pattern of the crop growth, yield, and productivity, and also on the different aspects of the output quality. In the influence of the climate change, we are seeing terms of the global warming, increasing temperature. So, after knowing the climatological situations, climatological conditions of the region, we will be more efficiently able to develop adaptation strategies to mitigate, adopt the climate in era of the climate change. So, situation of the climate change is being worsened in the recent years as compared to the previous years. Data has been taken from the WMO, where uh, they have declared that year 2025 was the third hottest year that has 1.43 degrees centigrade above the average temperature of that 1850 to 1900. Successively, year 2024, which started with a strong El Nino, remained the warmest year with 1.55 degrees centigrade above the average. Means 2024 was the warmest year, and 2023 was the second warmest year, and now 2025 has been the third warmest year. Means all when we are seeing the last 3 years, that has been the warmest years of the record as declared by the WMO World Meteorological Organization. Because of the increasing temperature, Earth energy balance has been imbalance has been the highest. Extreme weather events are affecting millions of the human lives, and it are posing the cost in the billions of the dollars. So this year has been declared by the WMO as observing today to protect tomorrow. This is the theme of the World Meteorological Day for the year 2025. This is another schematic representation of the Earth energy balance, obviously from the World Meteorological Organization, where they have demonstrated that how solar energy is coming with the same pace in the balance and imbalance system, but the outgoing energy is almost similar as the incoming energy. So system is in the balance state, but now the incoming energy is being absorbed by maximum by ocean 91%, followed by the land 5%, ice 3%, and atmosphere is absorbing the heat by 1%. So when we are these systems are absorbing the heat, so energy balance is imbalanced. This is the major problem, and now it has been highest in the 2024 in comparison to the last 65 years. The imbalance has been recorded highest in the year 2025. That's why ocean heat content of the year 2025 has been reached at the highest level in the record. from 1960. Previous, it has exceeded the previous record set in the year 2024. This is very what's a challenge before us, that ocean has continued to warm and absorb atmospheric CO2. It has been absorbing the equivalent of 18th time of the annual human energy used every year in the past 2 decades. Means, in comparison of the average 2 years decade, now we have it almost 18 times of the annual human energy use. Annual ice extent in Arctic was at a near record low. Antarctic sea extent was the third lowest in the year 2025. That's why the UN Secretary General Dr. Antonio Guterres stated that the global climate is in a state of emergency. Now, planet Earth is being pushed beyond its limit of tolerance. Therefore, every key climate indicator is being flashed red. Every successive years, we are moving from stress to more severe stresses. India is particularly vulnerable with such type of climatic change because it's just above the equatorial region, and the line of the Tropic of Cancer just passes between the country. The lower region of the country where temperature is high, but terminal temperature range is very low. In comparison of the lower or southern part of the country, the northern part of the country has also higher range of the temperature and higher temperature. So such type of the climatology is affecting the agriculture, livestock, and hydrological sectors. Other features which are affecting the climates of India are distribution of land and water, distance from the sea, when we move from the coastal area to the northern and part of the country, distance from the sea becomes more, and the climate will be different from the coastal climate to the north and northwest India. Similarly, the altitude also affects Indian climate reliefs, jet streams, surface wind patterns. Western disturbances particularly affect the winter season climate of the country. El Nino, Southern oscillation also affect the climate of the country. Seasonal patterns of the rainfall distribution and variability has been greater impact on the climatology and the Indian agriculture. We said that during southwest monsoon period that exists from June to September, the ITCJ is a low pressure zone temporarily shifted from the south to the north, which enables the movement of the pressure zone from the south to the north as a result of the increase in the temperature during the monsoon period in the summer season at the uh, northern part of the country, including Rajasthan, Punjab, Haryana. This is in general climatology of the country where monsoon onset and withdrawals govern the agricultural operations. start and end of the agriculture season, monsoon season. So in general, onset of the monsoon start in the 1st June in the south most part of the country, and gradually it shifts from the south to the eastern and northern parts of the country. However, withdrawal is also different. Withdrawal date is different at different locations. This is a pattern of the monsoon advancement in the year 2025. I tried to classify the climate of the ICR Niasam Baramati using Köppen's climate classification system, and found that the annual mean temperature is 18.9 degrees centigrade. Total rainfall is about 737 millimeter. Minimum temperature is 13.8 degrees centigrade. Maximum temperature lies around 22 degrees centigrade. Summer rainfall, including April to June, uh, is about 646 millimeter. Winter rainfall is 90 millimeter. Summer rainfall is just 0.9 millimeter. So threshold, as explained by the Köppen, was 657 millimeter. So major climate type of the ICR Niasam Baramati has been categorized as the CWA category, C, capital C, which uh, describes that monsoon is a, and that here is monsoon type climate is influenced by humid subtropical climate characterized by hot, humid summer and dry winters. This is annual distribution of the rainfall and climate of the Niasam Baramati. Here, maximum rainfall is received around June, July, and August. And at that same time, temperature starts from mid of the April and remains high up to the September, October. So, summer crops and crops, rain season crops are very uh, crucial for such type of changes in the temperature and rainfall pattern of the site. So all the climatological characteristics of, of the site, particular site is being affected, and which ultimately have a crucial role in the agricultural productivity. And due to the abrupt changes in the climate and weather system of a location, production risk has been increased in terms of the crop selection of the sowing time, harvesting time, and energy balance. Weather related risks are the heat wave, cold wave, dry spells, flood, droughts. These are also increasingly day by day. And pest and disease dynamics has been changed due to the change in the climatic and weather situations, outbreak, infestation, and migration of the host and pathogens have been increased due to the changes in the climatic systems. Financial risk and has been increased, therefore insurance related cost has been increased. Overall market risk such as commodity flow transport has been affected, that this whole system has been affecting the farm income, and because of the changes in the crop productivity and agricultural outputs. Major abiotic stresses and extreme weather events such as drought, flood, heat wave, thunderstorms, hail, stormic, and cyclonic activity affect the agriculture. So we will be discussing the nature and pattern of these extreme events in the country. So extreme events are frequent meteorological phenomena which has been increased from defined thresholds in terms of the normal occurrence. These extreme weather events may be defined as disasters based on the interference between the extreme physical events and vulnerable human population. One important aspect of extreme event is the apparent randomness and abruptness. Means there is no set pattern on the occurrence and distribution of these extreme events at particular location and state or the country. So determination of extreme weather events are based on research and certain approaches described by the India Meteorological Department. If cold wave may be declared under three conditions, cold wave when minimum temperature is 10 degrees centigrade or more, cold wave when minimum temperature and departure is between 5 degrees centigrade to 6 degrees centigrade below the normal, and severe cold wave can be declared if the departure of the minimum temperature in about 7 degrees centigrade or more. Cold wave planes based on the normal temperature departure by the 10 degrees centigrade. Cold wave in the planes can be declared by the 4 or 5 degrees centigrade departure from the normal, and severe cold wave in the planes can be when minimum temperature reaches at 6 degrees centigrade or more. Similarly, drought can be declared when rainfall departure is between minus 25 to minus 50%. Severe cold drought can be declared when rainfall deficit is more than 50%. When wind speed is 39 to 74 km per hour, it may be described as the dust storm, moderate dust storm. And when 75 km or more horizontal wind speed can be declared as the severe dust storm. And when wind speed is more than 75 km per hour, then it may be described as the extreme dust storm. Hailstorm have been categorized based on the size and mixture of the rainfall into slight hailstorm, moderate hailstorm, and heavy hailstorm. Similarly, such as condition was the cold wave, heat wave can be described if maximum temperature is 6 to 7 degrees centigrade above the normal, then it will be moderate heat wave. And when maximum temperature departure is more than 8 degrees centigrade, then this condition is called as severe heat wave. Similarly, there are different types of extreme weather events, and there are certain different criteria for describing and declaring the each type of events. So this is historical overview of the extreme weather events recorded in different parts of the country. Here you can see that Odisha cyclone has, has been recorded in 1999. Heat waves have been recorded in year 2003, and drought conditions have been recorded in 2000, 2001, and 2002 was the severe drought year. Just after 1 year in 2003, when rainfall was surplus, again drought has been experienced because of the deficit in the July rainfall. Uh, Year 2009 has been recorded as the biggest drought year. So, what we are observing that almost every year we have different categories of the extreme weather events at different parts of the country. So, livelihood, agriculture, horticulture, and many more sectors are affecting because of the changes in these events. So, extreme events can have either positive events impact or negative impact. Positive impacts may be fixing of the atmospheric nitrogen due to thunderstorm, germination of many native plant species results from the warming caused by the bush fires, maintenance of soil fertility because of the river flooding. Dry spell is sometimes beneficial at the harvesting and pre-harvesting stage of the crop because with uh, rainfall at the later stages we experience delay in the harvesting time, and particularly uh, quality of the grains are hampered, so marketable price and net income are affected. So when rainfall is not at the later stage, it may be beneficial for the crops. And because of the drought and less in the atmospheric soil moisture, there are less chances of the pest and disease occurrence. Our negative impacts are more than the positive impacts. Some negative impacts have been already described as in terms of the temperature increase and in climate change. So drought and how drought can be declared, how and what with what intensity and severity of the drought incidents, what are the criteria for the drought declarance has been discussed. Drought is considered as the most important natural disasters because it is covering l- large part of the country. According to the National Commission of Agriculture, there are four types of the meteorological drought. Four types of drought are meteorological drought, hydrological drought, agricultural drought, and socioeconomic drought. And all these types of the droughts are interlinked because, uh, for example, you take the meteorological drought, which is the departure of the rainfall by the 25% or more. When rainfall will be less, there will be less stream flow, less water for the stream flow, soil moisture storage, etc. That affect the water table and the hydrological situations of the area, resulting the water deficit in the in the rivers. and the underground water systems. So when meteorological drought and hydrological drought both are experienced, then overall agriculture system can be affected. And when agriculture is affected, the socio-economic situation of the location is negatively affected. So when we receive the high level of the climatic variability and variability of the rainfall, in terms of the deficient rainfall, drought is declared. When rainfall is deficit, it will be affect infiltration, runoff process, deep percolation, and overall the groundwater recharge of the area. And when it is associated with the high temperature, wind speed, and low humidity, so overall combination of the rainfall and these climatic variables, overall increase in the evaporation and transpiration is experienced. So overall less groundwater recharge and high evapotranspiration is experiencing meteorological drought type of the situation. And when it is combined with this deficit soil moisture, the plants feel water stress type of the situation. So overall plant stress, hydrological stress have certain negative impacts on the socio-economic conditions of the region. Agricultural drought is further classified in the early season, mid-season, and late season drought. This is the situation when we have normal rainfall, but with the start of the season, there is no rainfall. So it can be described as the early season drought because of the uh, delay in the monsoon and monsoon break. Dry spells are major reasons for occurrence of the early season drought. And when drought is experienced in the middle of the August, it it will affect the agriculture because at that time, especially in India, we have kharif rice, and rice is at the establishing stage during this time. And as per the recommendations of the kharif rice, and after transplanting up to 2 weeks, we have to full the field up to 2 centimeter from the water for the first 15 days. And when such type of drought occurs, no rainfall or less rainfall during these periods, it we lead to the over pumping of the groundwater resources that impact the higher agricultural cost and lots use of energy resources. Similarly, when the rainfall is not received in the month of the September or the last week of the July, August, then this situation is called as the late season rainfall, late season drought. And this is particularly important that during this time, soil moisture deficit can increase the negative impact on the grain filling and what grain size. Because of the less moisture, grain size is reduced, and uh, appearance of the wrinkle appearance of the grains are less preferred in the market. Therefore, it will get lesser income. So meteorological drought is departure of the rainfall from the normal or long period average. Mild drought can be declared when rainfall departure is less than 25%, and when rainfall departure is between 26 to 50%, it is moderate type of drought. And when rainfall departure exceeds 50% deficit, then it is termed as the severe drought situation. These are some indices which has been used for declaration of the drought events. These are the among them, Palmer drought stress is most important parameter, which is based on the precipitation and temperature data. And this approach applies the water balance method to declare the drought. When rainfall departure and soil moisture balance is considered, and Palmer drought index is calculated, when PDI values lie between 0.49 plus minus 49, then it is normal. And when we increase the PDI value from towards positive sides, then it is bad. And when we are moving from the positive to negative side, then it means the rainfall is deficit and drought conditions are more. As extreme values are categorized based on the high values of the PDSI. This is soil moisture deficit index to declare the drought. This is the ratio of the soil moisture departure. This index is based on the crop's specific soil water balance model. Soil moisture deficit ratio is calculated for a given period based on the long-term mean soil moisture, maximum and minimum available soil water status. This index is also calculated following Palmer's 1965 procedure. Another important index to calculate the drought is SPI, Standard Precipitation Index, which is the ratio of the difference between precipitation and mean temperature to the standard deviation of the mean rainfall, average rainfall of the region. In this index, two parameters in complete gamma distribution is fitted to the long-term rainfall data to normalize the time series. So, using rainfall data and the long period average and standard deviation, the standard precipitation index can be simply calculated. So, this slide has been summarized for different indexes to calculate the different types of the drought, what parameters have been useful for calculating these types of the drought, and what are the formula to derive these indices are presented here. So by changing varietal manipulation, drought escaping and drought resistance, drought can be managed in the area of recurrent drought. Mid-season drought can can be avoided by life-saving irrigation and prolonged dry spells. Avoidance with the life-saving supply of the life-saving irrigation, light irrigation, moisture conservation through the use of mulch, interculture operations may be important for such type of mid-season drought. At community level, drought can be managed by participation in the watershed planning, by applying implementation of the water conservation initiatives, secured water supplies, and avoidance of the water wastage of the water. So similarly to the drought, floods can also be uh, important for the different regions. These are some glimpses of the flood affecting the peoples in different sectors. So what we have seen in the previous slide, that either flood or drought, these are very common natural disaster or extreme weather events which has been experienced in the several parts of the country. These are certain reasons why floods are experienced. Heavy rainfall and low pressure systems, these are the main physical parameters. Heavy rainfall during the active south monsoon best period. Heavy rainfall over mountains and catchments leads to the stream flow towards the downs, and it is often associated with the risk of the landslides. Abnormal warmer temperature on glaciers are causing snow melting, which are also affecting the coastal area. Sudden discharge of water from reservoir due to break of dams, and in cloud bursts, snow melts, seismic events, tsunamis, etc., are also creating the floodslide situations. Sometimes blasting and during the construction works also damage the walls of the dams, and because of that, water flows down and act like a flood-like situation. Inadequate drainage network are important because when rainfall is more and there is no sufficient channels to remove the water from the field, flood impacts will be high. Obstruction to the drainage systems, riverside and water channels are certain regions. So floods may be coastal flood, river flood, urban flood, flash flood, groundwater flood, and sewer flood. These are the flood-prone regions of the country. The area vulnerable to is about 40 million hectares, and average area affected by flood is 8 million hectares. Based on the percent geographical area prone to flood incidents, most parts of the Punjab, West Bengal, and some districts of Bihar and Uttar Pradesh are much vulnerable to flood. These accounts about 60% of the total geographical area of the country. These are certain adaptation measures to manage flood and heavy rainfall situations in experienced in the agriculture system. Long-term weather data analysis and identifying the excess rainfall period is important by this we can manage or adopt our crop. Use of flood resistant varieties and contingency crop planning. Drainage management to manage excess rainfall and flood waters. Archers which can withstand to flood waters can be promoted. Classification of flood zone and accordingly the management plans and development of policies for those situations will be important. And these are the heat waves. Heat waves are declared when temperature is at least 40 degrees centigrade in the plains and at least 30 degrees centigrade in the hills. When maximum temperature of a station is less than or equal to 40 degrees centigrade, it is heat wave. And when departure of normal maximum temperature is uh, 5 to 6 degrees centigrade, it is mild heat wave. And when departure is more than by 7 degrees centigrade, it is severe heat wave. When normal temperature of a station is more than degree centigrade for that region, it will be declared when departure is between 4 and 5 degrees centigrade, and if 6 degrees centigrade maximum temperature departure is, then it will be severe heat wave. When actual temperature remains 45 degrees centigrade or more, irrespective of the normal maximum temperature situation, heat wave will be declared. So this is very important criteria to declare heat wave. Heat waves form when high pressure aloft from 10,000 to 20,000 feet strengthens and remains over a region for several days or up to several weeks. Under high pressure, the air subsides towards the surface. The sinking air acts as a dome, coping the atmosphere. This cap leads to trap heat instead of allowing it to lift. No cloud develops and clear sky, making situations passing the radiation to more frequent at the earth. Then the end result is a continual buildup of heat at the surface in the form of heat wave. Global warming boosts the probability of the extreme weather events, and heat wave events are projected to be more during the coming years. Widening of the probability distribution of temperature can affect the probability of the extreme weather events due to relative impact of the shift. Models predict that the summer times 5% high temperature recorded once in the 20 years and will now occur at least 70%. Means the what temperature situation where 5% during in the 1951 and 20 to 80, now it will be about 70% in the up to 2064. Natural variability continues to play a key role in extreme weather. Climate change has shifted and natural limits has been changed. Therefore, heat waves events are more frequent and intense. Atmospheric circulation, El Nino, and other phenomena determine which regions of the globe will experience extreme climatic events. These are the severe heat waves records of India. First recorded heat wave has been experienced in 1995 June, when 45 degrees temperature increased up to 45.5 degrees centigrade, and it has led to more than 350 people's death. In May, June 1998, temperature recorded was 49.5 degrees centigrade. Death was 2,500. April, May 2002 experienced 49 degrees centigrade and 1,030 deaths. May, June 2015 also recorded 49.4 degrees centigrade, and corresponding population death was about 2,500. Similarly, in the successive year to April, May of 2016, temperature recorded the maximum 51 degrees centigrade, and the ratio of the death has been nicely managed up within 160 days. May, June 2019 also recorded high temperature up to 50.8 degrees centigrade. Corresponding death was 184 people. March, June 2022 recorded 49.2 degrees centigrade, and death has been nicely limited to 90. April, June 2023 experienced 46.2 degrees centigrade, leading to 111 people's death. April, June 2024 experienced 50.5 degrees centigrade of temperature, and corresponding death has been increased to 411 people's. So, what crucial in this slide that in comparison to the early years, the frequency of the heat waves in recent years has been increased. Almost every year we are experiencing the high temperature related events, and the associated risk has been increased. Although we have nicely managed the death related events because of the high temperature and heat waves, but every death counts, every people are important. So if we should not be satisfied that we have managed the death caused by the heat wave from 2500 to 90 or 111. Every death are important and accountable. So until or unless our efforts should be to reduce this line up to zero. On the agriculture sector, how high temperature affects when 1 degree centigrade temperature in North India, it will affect about 4 to 5 million tons of wheat loss, wheat yield loss. Increasing temperature will affect the yield of cotton, fruit, vegetable, tea, coffee, and aromatic plants. Quality of the rice, basmati rice, and production of the apples are already influenced and have been reported. Pest and disease occurrence has been increased with gradual and light increase in the temperature situations. When temperature increase will be more, then under those situations, yellow rest in the wheat will be affected. Global warming can reduce the milk production of the country. 1 to 2 degrees centigrade increase in the mean temperature. The water reservoirs such as ponds and rivers can enhance the fish mortality and the migration of the fish. These are the practices how we can adopt our plant to different type of biotic and abiotic stress. So yield is basically governed by the genotype and environmental factor in addition of the management practices. Drought stress tolerant genotypes can be developed through genetics, breedings, biotechnology, and speed breeding systems. Development of resilient techniques and methodologies to screen the cultivars. And when we linked development of the cultivar development program, varietal development program, along with the abiotic stresses of prevalence in a particular region, and also the abiotic stresses such as plant disease, pest, virus, nematode, insect, weeds, etc. So beyond the genotype and environmental factors, different management practices are important to develop region-wise, crop-wise, to reduce the extent of the yield loss. Uh, this is an example of the temperature increase by 2.5 degrees centigrade or 4.9 degrees centigrade. The model situation is then rice yield will be decreased by 15% and if temperature increases by 2.5 degrees centigrade, and wheat yield will be more vulnerable into decrease by the 25 degrees centigrade. And if the situation of the extreme weather events are high temperature increases by 4.9 degrees centigrade from the ambient, then rice yield and wheat yield will be decreased by 29% and 42% respectively. So, how plant behave under extreme weather events? Heat stress damage protein membranes and reduce photosynthetic ability of the plant. Similarly, cold stress cause ice formation, rigid membranes, and enzymic activities. Both stresses affect the water imbalance in the plant. A common effect of both stresses, heat stresses and both cold stresses, lead to development of the oxidative stresses within plant system. Heat adaptation include heat shock protein, leaf rolling, and deep root systems. Cold adaptation include antifreeze proteins, osmolyte developments, and dormancy nature. Both the heat and cold stress triggers hormonal changes and gene expression. If stress is severe, the circular cellular damage will be more, and ultimately yield will be highly reduced. With successful adaptations options strategies, plant survival and recovery can be maintained because plant can adjust to extreme temperature, but stress can still limit the productivity. This is the cold wave situation. Under cold wave, western disturbance moving west to east are extratropical disturbance that manifest as weak troughs of low pressure of 4 to 6 kilometer height over the northern plates of the country during winter season. As they originate around Mediterranean region, they bring in rain and cold weather. The phenomena can last up to 1 week, causing cold wave conditions. Its impact may be manifold when they occur in a sequence, adversely affecting agriculture and human lives. This is the cold wave criteria already discussed in the tabulated form. When departure of the minimum temperature is 3 to 4 degrees centigrade, it is cold wave for the regions where minimum temperature is less than 10 degrees centigrade. And when departure is 4 to 5 degrees centigrade, it will be the cold wave for the regions where minimum temperature is 10 degrees centigrade or more. Similarly, situation of the severe cold wave will be 5 when minimum temperature departure will be 5 to 6 degrees centigrade above the normal and 7 degrees centigrade above the normal for the regions of less than 10 degrees centigrade and more than 10 degrees centigrade. Minimum temperature affects the plant through chilling injury, which is experienced when minimum temperature reaches 0 degrees centigrade to 2 degrees centigrade. It causes several physiological disruptions and hampers seed germination, plant growth, and delay in the flowering. Similarly, minimum temperature affects through freezing injury, in which water in the cells freezes, and when ice crystals forms within the cells, it cells damage and experience dehydrations and lead to plant mortality. Light freeze of minus 1.7 degrees centigrade to 1 degree centigrade temperature. Tender plants kill with little destructive effects on the other vegetation. Moderate freezing up to 3.9 degrees centigrade. Wide destruction occurs because of the which damage fruit blossom, tender and semi-arid hardy plants. Severe freeze up to 4.5 degrees centigrade minimum temperature departure. Severe damage to plants. At this temperature, ground freezes and depth of freeze depends on soil type and soil moisture. This is the picture of some cold wave affecting the mustard crop, papaya, jatropha, tomato crop, potato crops, field pea. This is the symptoms of the cold wave experience. A white spot ring encircles the stem at the juncture of the stem and flag leaf at the time of freezing. Damage may occur in different areas of the spikes because flowering, which is the most sensitive stage to freeze, does not occur at the same time in the floret. Burning and yellowing of leaf tips are common in spring freeze symptoms at the tilling stage of the crop. More severe freeze damage caused the entire leaf to turn yellowish white and the plant to be limp. A silage odor may be detected after several days if the situation prevails. So, cold waves effect in the plants also can be managed by application of the heaters, irrigations, wind and fogging, and uh, different indigenous practices and ancient knowledge has been also applied being at different places to avoid the cold wave impacts on the agriculture. Fishes and livestock are vulnerable because of the cold stress as their favorable limits for maximum production is 7 to 25 degrees centigrade. Greater than 7 degrees centigrade during the 2002 and 2003, cold wave reduced 20 to 25% milk production in Agra. Cold wave results in hormonal and adaptive changes in livestock, reduced digestive efficiency, increased glucose oxidation, and overall effects in the fertility rates. Water temperature up to 10 degrees centigrade is adverse to growth of Indian crops. Decline in feed intake, stress for the fishery, low growth, and below 4 degrees centigrade, the mortality rates increases sharply in bottom feeders, low-lying fishery. Extreme mortality in plants also observed because of the less availability of the dissolved oxygen. This is the situation of the thunderstorms and hailstorms. The transformation of winter into spring and up to March and May, the temperature giving rise to thunderstorm and squally weathers. India is among the countries in the world having large frequency of hailstorm. This is the impact of the hailstorm recorded on wheat, maize, apples, citrus, and mustard. At any stage, occurrence of the hailstorm has been experiencing uh, has negative impacts on the crop. So this is the life cycle of a thunderstorm. It has three stages: cumulus stage, which in which stage water vapor is moved aloft by updraft wind, vertical cumulus clouds develops, and maturity stage. Once the cloud reaches the freezing level, precipitation forms via the Bergman process. Falling precipitation produces a drag on the surrounding air, causing cold downdrafts. And last, the dissipating stage, when downdrafts dominate and moisture input from surface ceases. This is protection from hail. So use of hail nets and covering of the important crops, use of zippers nets are some important. Uh, yeah, uh, flash flood and cloud burst are also important phenomena related to agriculture. Cloud bursts are sudden copious rainfall falling for a short period to small geographical area with greater than 100 mm or more than 20 millimeter within few minutes. Cloudbursts are often associated with the thermal storms. The air currents rushing upward in a rainstorm hold up a large amount of water. If these currents suddenly ceases, the entire amount of water descends onto a small area with catastrophic force of all sudden and cause mass destruction. 1900 rainfall has been experienced in Mumbai due to rapid condensation of the clouds. Cloudburst occurs most often in deserts and mountainous regions and in interior regions of country, continental land masses. When there are an instance of the cloudburst, the results can be disastrous because these are often associated with the flash flood types of the situations. These are some pictures of the cloudburst. Then cyclone. Cyclone is also a very important natural phenomena for the coastal agriculture. The tropical cyclone is intense low pressure Tropical cyclones is an intense low pressure system with strong winds circulation. Tropical cyclone feeds on the heat released when moist air rises and the water vapor condenses. The movement of the cyclone uh, and cyclone characteristics, average distance covered is about 360 to 480 kilometer. Wind speed, normally cyclone moves from west to northwest direction. Sometimes it may change the direction of movement toward the north or northeast. This is called recurvature of the cyclone. Uh, we have taken certain initiatives to manage the extreme weather events and monitor the abiotic stresses in the agriculture at ICR Niasam Baramati, Pune. We have taken soil data between 2015 and 2020 from different parts of the country and describe the nutritional map of the country, and results revealed that many districts are often deficient in the nutrition, simultaneously into 2 to 6 types of the nutrient deficiency has been experienced. 12 districts are having low soil nutrition across 6 major nutrients in NPK, nitrogen, phosphorus, potash, sulfur, zinc, and borons. And 319 districts of the country have very low nitrogen and carbon content in their soils. So when such type of picture is available with us, we can develop the location specific crop management practices, nutrition management practices, and fertilizer application and scheduling plans. Use of the remote sensing technology has been very elaborately discussed by the Dr. Mohanty in the previous lecture. So, how we can use the advanced information and technological knowledge in our system? We tried to count the tree population and livestock population with the help of the remote sensing data. This is the situation of the uh, pre-observation, and this is the situation when we applied the imagery. Drone has been used to capture the image-based counting of tree at different orchards of the institute, and we have developed almost a very good we have developed very good accuracy for counting of the trees using the drones and the image based softwares. Similarly, we have developed abiotic stresses of the Maharashtra regions. These are the abiotic stress indicators map. The district wise map has been developed for entire Maharashtra. So, briefly, multiple factors contributing to geospatial assessment of abiotic stresses are soil depth, soil texture, relative slope position, soil moisture, soil fertility, drought, very heavy rainy day, and heat waves were combined into single abiotic stress score map for the Western Maharashtra with the 30-meter resolution. And the results revealed that more than 90%, 94% area of the Western Maharashtra was under high abiotic stress. Means about 95% is situation region of the Western Maharashtra is under high abiotic stress situation. Similarly, this is the sustainability map of the rice crop productivity of Bihar. Here, this region is low and unstable for the rice cultivation. That includes Katihar, Hazaribagh, Palamau, Patna, Gaya. So these are the unstable zones, and this is the low but stable zones includes Champaran, Saharsa, Singban, and Ranchi districts. And this is the top right corner are high and productivity zone and stable productive zones are the rice cultivation in Maharashtra. So this has been sorry. Yes, sir. It is finished, sir. But I think uh, presentation has been stopped. Yeah, sir. It is finished. Thank you, sir.